Hello, I'm Dave Eicher, editor of Astronomy magazine. Welcome to this Cosmos Rewind Google Hangout, as always sponsored by Celestron. This past episode of Cosmos: A SpaceTime Odyssey was called The Immortals, and it focused on various themes related to life, both here on Earth and elsewhere in the universe. Let me introduce our Hangout panel for the day, if I may. Bill Andrews. Bill, great to have you back with us. Bill is Associate Editor of Discover magazine. Rich Talcott, Senior Editor of Astronomy magazine. Rich, great to have you back with us as well.
Thanks, Dave.
Sarah Scholes, Associate Editor of Astronomy, but not for terribly long, because Sarah is going to California to write a book about astrobiology. So I hear, so that's going to be something, and myself. And so I'm going to go back to Bill now, who will give us an episode summary of what are the Immortals all about here, Bill?
All right, well, as you can imagine, the theme of immortality came up a little bit and how we might be able to escape some of our fates in the future. So it was an interesting episode. Let me just get right into it, and then we can all talk about it. All right. Must we die? Neil asked provocatively at the start. We find ourselves in ancient Sumeria in Uruk, what's now Iraq, with the princess Enheduanna, the first person ever to get a byline. Because she signed her name to her poetry, Neil says hers is the earliest mind we can know. She's the first person ever to reach a kind of immortality. Neil then goes on to talk about Gilgamesh, who epically sought out literal immortality. We actually spend kind of a lot of time with him, and at one point we cover a familiar story, all about this great flood that destroyed everything, and there was an ark that saved mankind and the animals. It'll make sense in a little bit why that came up. In the end of the story, though, Gilgamesh only achieved the fake kind of immortality, as I think of it, the same as Enheduanna. His deeds and thoughts will live forever, but he won't. He actually died. Or he will die. So, speaking of living forever, DNA kind of lives forever, Neil tells us, at least in the sense that our genes are stories that have been told throughout the generations, written in the letters of the individual sugars and the DNA strands. We can trace our genetic code back through the ages, but ultimately the search ends in a question mark. We just don't know how life started. Neil talks about a few options, some tidal pools and heat vents in the oceans, before really diving into a more, shall we say, provocative hypothesis about panspermia, the idea that life on Earth was seeded by extraterrestrial life hitching a ride. That turns out to be, totally possible. Mars rocks really can end up on Earth, and experiments show that, it's actually totally possible for certain hardy forms of life to survive trips out into space and back. And here's where the talk about the flood and the ark comes in, because Neil points out that it's possible that even if huge impacts sterilized our planet multiple times in the past, life could have survived it all by hanging out in the rocks that got shot out into space and eventually fell back to Earth. So I guess it's possible, technically, that life could exist throughout the galaxy, seeded by these plausible-ish interstellar arcs. Then Neil switches to another kind of space transmission, not of life, but of communications. We've been searching for extraterrestrial intelligence for decades now, and have found nothing. Plus, our TV and radio broadcasts have been drifting out into space too, as depicted in a scene that very much reminded me of the movie Contact. What a shock. Maybe we haven't heard back from anybody in all that time, despite all our missions, because the aliens are too smart for our primitive communication systems. Maybe they can't even pick up that lonely stuff. Or, Neil says, maybe it's that they're all dead. Just as Enheduanna and Gilgamesh knew for sure, nothing can live forever, and that includes civilizations. Maybe it's just too hard for planetary civilization to live long enough to communicate with another one. Finally, we end on a little bit about what might do our civilization climate change, before taking the opposite tack and looking forward. Neil expanded on that cosmic calendar and talked about what might be possible for our species in the next few thousands and millions of years in our own interstellar arcs. Perhaps one day our species might actually reach immortality. You know, maybe. That's what I thought the episode was about.
What did you guys think of it? What was your take on the episode here? Because a lot of people really liked this and some didn't so much.
I thought it skipped around a lot, and so it might have been hard to follow. But on the other hand, I liked that it touched on a lot of the larger issues and questions. Maybe too many of them at once. You know, is there life? What is our civilization doing with and to itself? Should we have spaceflight to other stars? What might other civilizations be like? Lots of these bigger questions that are maybe more cosmic than like the other week's episode about lead poisoning. So I enjoyed that about it, but I know you guys have some thoughts about its speculative nature, which I agree with, but I think you'll state them better, so I'm going to hold back on those.
Well, I'll give my 2 cents here. I thought that the episode was well done for what it did, and I have to admit that I am probably not the target audience for Cosmos, which is geared more to younger people and getting them interested in science. But as I was telling my wife after the episode, this is the one where I finally gave up all hope that it would be what I was hoping it would be. For the first 10 episodes, I kept hoping, well, maybe we'll get some new science that's come in over the last 30-odd years since Carl Sagan's original Cosmos. And after Sunday's episode, I've come to the conclusion that that's probably not going to happen, and all of the great things that science has taught us about the universe in general over the last 30 years probably won't make an appearance, and if it does, it'll be so short as to be almost in passing. And so in that sense, this episode disappointed me a great deal, because I don't think it's getting to where I was hoping Cosmos would get originally.
Well, I'll just go next before Dave goes, because I think Dave and Rich might be on the same side about this, and not to draw lines and pick sides, but I think I might fall more into the I wasn't as disappointed by this episode. I was fairly well entertained by it. I liked watching it. I thought it was a pretty exciting one. Sarah's points about a lot of topics and a lot of kind of big question ideas, yeah, that's true. It could use a little more focus on that sense, but I liked how it kept tying back everything to this, idea of immortality. They kept showing those cartoon scenes of Enheduanna there in ancient Iraq, and everything kind of made sense in that way, in the sense that if you don't stop and think about it, it's really cool. And so as someone who's just watching it to be entertained, I thought it was pretty good. As someone who understands, some of the science and some of the stuff they're talking about, I might share some of the same concerns that we will be discussing shortly. But overall, I thought, there were other episodes I liked less than this one, so not too bad.
Well, and I would agree with Rich. I think that I'm, and again, I'm not the target audience for this show either. They're clearly a long way from it, probably. But I'm a little bit disappointed that these major things that have happened, areas that have developed over the past couple of decades, post-1980, since the first Cosmos, in astronomy, in astrophysics, in planetary science, in cosmology, that are big, big questions. Some of the biggest questions that we've thought about as a species ever since our ancestors looked up at the moon and stars and wondered what they were. Now we're getting close, just very, very recently, to the answers to a lot of these big questions, and the series hasn't really, as Rich said, hasn't really touched on these yet. So that's a bit puzzling, or even shocking, you might say, the coverage of the series. Now, I understand what they're going for here is to sort of show the scientific process and to explain through inspiring stories of various scientists or would-be scientists, how discoveries are made, how the human quest for knowledge gets pushed forward. That's really nice and a great thing for the series to be doing. But it is puzzling that it's doing that at the expense of talking about a huge, explosively large number of important topics that have developed over the past 10 to 20 years, largely. So that's a little disappointing. Also, I would take exception and say that just very specifically, actually, with this episode, and especially the first half of it, I was really disappointed with the actual coverage of talking about the origin of life on Earth and how it likely may have happened. And I thought that, you could sort of title this episode really, improbabilities and speculations to a large extent, because looking at panspermia and the idea that either through asteroid delivery or particulates coming down onto Earth, or through the passing through the interstellar medium and picking up organics or bacteria, or the components that would make life, those are plausible things, there's no doubt. And I talk about this is sort of intensely fresh in my mind because I just edited a book chapter for this Starmus book that's going to come out this summer, that Jack Szostak of Harvard wrote on the origin of life, and he's a Nobel Prize winner, and he's really at the forefront of looking at this stuff. And I thought it was odd that we had this focus for so long on here's what might have happened. Well, that's true. But, this is sort of putting a blindfold on and ignoring the fact that organic chemistry was going on early Earth, right here on early Earth the whole time, too, and that it was much, much, much more likely that organics, we know amino acids were here, we know they exist on early Earth, they also exist in meteorites and comets, and the fact that they were here in large numbers and that early Earth was a cool, wet environment. And I think the business about very large impacts with planetesimals was exaggerated, frankly, because that cooled out significantly before the era of life began on Earth, insofar as we know it from fossils of about 3.4 and a little older billion years ago. So, why put a blindfold on and say that, well, the organic chemistry of amino acids and proteins and we believe polymers that led up to RNA, let's not even consider that in hydrothermal vents or worm pools or wherever, and let's consider this extremely unlikely, by comparison, idea of organics coming in from space. You don't need to invoke the very unlikely when you have organic chemistry going on all over the planet ubiquitously with the ingredients that were already here all over Earth. And I just want to show one thing quickly, and I'll end my sermon. But this is an ugly rock. It's actually a mineral called Montmorillonite. And Szostak writes in his chapter about some research that has been done over the past couple of years about this. This is very common stuff. It's a clay mineral. It forms from the decomposition of volcanic ash. And it's actually sodium, calcium, aluminum, magnesium, silicate hydroxide hydrate. And there's actually a lot of work that has gone on with people at Harvard and elsewhere showing that this mineral actually facilitates the linking of the little units that make up RNA. It brings those together in vesicles and links them and makes the formation of RNA quite likely on early Earth. And that's something that's really complicated and you can get into, but there's a lot of work being done on this now. So I was disappointed that here we invoked this sexy, mysterious, weird idea that is a tremendous long shot, whereas we had ubiquitous organic chemistry, we believe, going on all over Earth right here already. So that was sort of turning the focus, I thought, away from what we actually know about science and science as a process, and turning it on to this fun or exotic thing that people could think about, that maybe life came in from asteroids or from the interstellar medium. That was disappointing. And also the exaggeration of the hostility to life on early Earth, I thought was really not handled well, or handled really very precisely. So that really disappointed me, and as you might be able to tell, kind of set the tone for me and soured me a little bit on this episode. But let's talk about other things. What else did you find interesting in this episode other than the origin of life? Or we can talk more about that too.
Well, before we move on to that point, Dave, I think that, I'm sure, like you're saying, what they were going for was this sexy, exotic thing that maybe people haven't heard of, that's maybe sounds more exciting than these other more Earth-based ways that life could have arisen. But what maybe they forgot is that it's kind of incredible however life arose, whatever way it was from. And just the fact that that happened, whatever way it did happen, is, incredible and amazing, and it's great that we can investigate that and try to figure it out. And it would have been maybe nice to see them play up the sexiness of real science and figuring out how you look at this thing from so long ago and find out how it came to be us.
Agreed. And, and obviously, as you can probably tell, this is a bit of a sore point with me, but, I think it mirrors this fact that we live in this culture where every blog and every tweet is latching on to the latest, coolest, neatest, most exotic, most unlikely thing, and at the expense of telling the rational, balanced story of what probably actually happened. Now, that's fine on blogs, and where anybody can write a blog about anything, and in the Twitterverse, likewise. But you'd hope that a show like this, that is really casting a light onto the next generation of how people think about these things, would feel a responsibility to be objective and to be balanced. That's what upsets me, and I'm sorry.
Yeah, I thought it was kind of unusual that they did not have a lot of scientists that looked at the early origins of life here on Earth. For instance, the Miller-Urey experiment that showed that you can get some of the precursors of life from conditions that were presumably common on Earth early on. And they've done a lot of good work in the earlier episodes of talking about the scientists behind what's going on, but there wasn't that much in this one. And as you said, we went off to panspermia pretty quickly.
And mind you, it's a long, long way from amino acids to get all the way up to RNA. And there's a lot of debate about which came first, proteins, RNA, or DNA. But a lot of sort of overwhelming feeling is that we may well have lived in an RNA world first that got things going and got the replication of molecules. And my point is, just in the last year or two or three, there's a lot of research, including this ugly rock and lots of others, and lots of other factors, about how we could have gotten that mysterious, big, complex jump from the building blocks of protein all the way up to the molecules, the nucleotides that really define life, RNA. And so why not, make some noise about that? That's pretty astonishing and pretty important. And that was sort of left in the pale. So anyway.
Well, I just
enough of my yak.
No, I think this is an important point. It kind of goes to something we've been talking about in the past, which is that while Cosmos doesn't, the current Cosmos doesn't necessarily say anything that's untrue, the true things that it leaves out are sometimes kind of bewildering. And I know last time we talked about, because the last time the episode was, what's his name? Oh, Faraday, Michael Faraday. And we talked about how kind of they made the choice to tell his story, and that comes at the expense of some of the other things that left unsaid, like Maxwell's life and his amazing contributions. And at that point, I made the case that I kind of understood their choice, that they wanted to tell the story to make the make it clear to the viewer, make it a good piece of television, and the science story that was telling, the stuff that was leaving unsaid was unfortunate, but so be it. And here, I think it's a similar situation, only I feel less okay about it in this case, because as everyone's been saying, the stuff that they left unsaid in this case is, A, fascinating enough on its own. Certainly the origins of life are not a really boring, topic for discussion. And B, the preponderance of evidence seems to be a lot more on the side of, the things that Neil Tyson dismissed so casually at the beginning. There's A and B, but let me tell you about C. And we spend like 10 minutes talking about C, the panspermia, when, okay, like it's not wrong. That is part of the story that you can tell here. But why would they tell that one? In this case, I feel like it's, okay, that might be a little sexier. Some kid channel surfing, finding asteroids, had a lot of wow. But some kid channel surfing and finding out these are the ways that life started on this planet, that's kind of wow factor too. I see where they're coming from a little bit with this. I know Fox is different from PBS in terms of the audience, in terms of what you can assume people find interesting. So I understand a lot of their choices have to be more, toward a different demographic. Even I, and myself included, I know that I'm a lot more into science. I'm not a regular guy in that respect. But at the same time, I just don't understand. Like you say, what kind of obligation do they have to these people? Now people are going to think that's maybe the overriding theory of where life came from. And I don't know. I mean, like I said, overall I still enjoyed watching the episode, but it is funny that they would choose this path.
Yeah, and I do agree with Bill in that I also enjoyed the episode. But going back to the obligation thing, I think when you're doing something that people are going to take as true, because you're presenting it as I, Neil Tyson, am the authority on this subject and I'm telling you about it, you do have a responsibility to present them with the real evidence if you want people to trust science and scientists. It's like, it made me think of, I don't know if this reference is too dated, but when the Da Vinci Code came out, that book, and everyone thought all of the things about ancient art and everything were just straight up true because it was presented as this historical thing, and then, people were upset when they found out it wasn't, except this is a science show, and it's supposed to be. Something I did like, though, and this is kind of a topic switch, so I hope that's okay, but was the way the show talked about different ways that things can be immortal or multi-generational, like Bill kind of brought up in his summary, the way that writing and legends written down are a way to continue have facts go between generations, and then also that things like spaceflight, if we develop long-term spaceflight, that would be like a kind of multi-generational thing to keep things going. And these transmissions that we send inadvertently or on purpose into space. And so I thought that was, despite how I thought that how the show was a little bit all over the place, that was a nice tie of all the stuff together.
And Sarah, that leads actually directly into our first Twitter question. What signals are we transmitting into space?
All your secret data.
Yeah, all of them. All the signals.
Much less than the NSA has, that's for sure.
Well, I mean, yeah, in a little way, in a way, it's all everything that gets kind of beamed, goes out into space. Radio, that just goes out into the airwaves, and then it keeps going out. Television, back in the day when it was sent out on the airwaves, also, it'll just keep going. If nothing stops it, it will eventually just keep going farther and farther out. As we saw in that scene, it expanded out, and I expected it to keep expanding out, and then you go past Saturn and past this, and then it turns out to be Jodie Foster's eye when she was a little kid, just like in Contact. But, I mean, that is a powerful idea that I'm glad they brought up, too, that all these things that we've been just beaming to ourselves, actually, we've been sending out to the whole universe.
And I've seen a talk by Frank Drake, the scientist who did the first search for extraterrestrial intelligence, showing actually how we're becoming a quieter civilization in terms of radio waves, and because of things like how TV broadcasts are digitized now and how we're not really as loud as we used to be, and we're not broadcasting as much out into space, which we never necessarily were intending to do anyway as communication, but now, you know, our TV shows don't go that way, and we might be harder to detect. Although, I mean, obviously our signals are still going out into space.
Yeah, of course, the farther away they get, the weaker they get, too. So our I Love Lucy and Honeymooners episodes from back in the 1950s are getting pretty weak when they're out 7 light years from Earth. So it's going to be hard for people to put together the signals and see Ralph Cramden talking to Ed Norton.
So you may see only half of that candy assembly line with Lucy and Ethel out at dozens and hundreds of light years. Let's talk a little bit about another interesting and controversial topic that is taken really for granted by most people as completely possible is interstellar travel, because sci-fi has conditioned us to believe that of course it's possible. You know, ever since the days of the original Star Trek and beforehand. Is interstellar travel really possible? Wouldn't it take a long, long, long time, despite improvements in technology in the future, given the laws of physics, to get even to the nearest stars?
Yes.
Yes.
To elaborate a little bit.
Thanks for coming today.
You wanted the experts? They're right here.
Yep. We all agreed.
Yeah, I would say the key thing to keep in mind is that with our current technology, there's no way interstellar travel is going to happen in the near-term future. And the reason, as you said, is just the vast distances that separate us. The Voyager spacecraft right now are the farthest man-made objects out in our solar system, and in another couple of tens of thousands of years, they'll reach kind of the border of our solar system, the Oort cloud of comets. And so to think about interstellar travel as being something that you get in your spaceship and in a couple of minutes or hours or even days you're flying by other stars is just so far beyond anything that we can work on at the moment that it's for all intents impossible under our current technology.
Wasn't it? Oh, go ahead. Go ahead.
No, you go ahead.
Well, all right.
Okay.
I was going to say, wasn't it like the Hitchhiker's Guide to the Galaxy that frames the issue well at the very beginning when it's saying, you know, space is big, really big. I know you think it might be a long walk to go down to the chemist on the corner store, but that's just peanuts to space. And I think that's very useful to keep in mind. It's almost impossible for our human brains to understand things at the scales of the universe. And as Rich said, it will take, you know, our best technology from decades ago that's farthest out than anything will take tens of thousands of years to get out there and even really hit the boundary of the solar system. But I just cling to the idea so much that physically, if we were interested in the idea, if we put all our capital into it, it is kind of within our reach to make a ship that people could have some kind of, it would be a multi-generational journey for sure, but it is theoretically possible to get people on a ship, and then eventually people related to them will end up at a distant planet, let's say, at another star. That is pretty much impossible, I know, but there's a big difference between pretty much and flat out. And so it is theoretically possible right now that we could do this. It would just take forever. Well, it would just take a long time. And if technology improves, if we develop a warp drive, oh my God, that would be great. But I mean, if while we're wishing for things, it would also be great, you know, to have a pony in everyone's backyard. So.
Well, another thing to think of is that if somebody from 1,000 years ago came to us today, they would think we were magicians because they wouldn't understand our technology at all, and they'd be so in awe of it that they would think that it would have to be done by somebody that knows magic. So who knows what's going to happen in a couple thousand years from now? Certainly technology is increasing at an exponential rate, and the possibility, as you said, Bill, is that one day we may be able to do something like it. But it's a long ways in the future, I would say. Past my life.
And there is actually a group that's investigating this called the 100-Year Starship. I don't know if you guys are familiar with them. I believe they have government funding to talk about what it would take to have some kind of multi-generational spaceship traveling beyond the solar system within the next 100 years. And there aren't that many projects that go that long planning-wise, just because of funding cycles and the government and things like that. So I think it's really interesting that there is this group that's trying to say, okay, what's our 100-year plan for how we would think about getting to this point? Not that we will be to this point now or anytime soon, but let's talk about it, because if we never talk about it, it will never ever happen.
Right, and I agree that it eventually could be hypothetically possible, but let's not use the backwards argument that looking forward to later technologies could perhaps violate the laws of physics.
No.
We understand them better, and we will certainly have incomprehensibly better technologies. But going back to technology 10,000 years ago and looking at the difference between then and now and extrapolating that forward 10,000 or 10 million or 100 million years from now doesn't automatically guarantee these things will of course happen, because look at how far we've come. That's a specious argument. So the laws of physics are still the laws of physics, regardless of the development of technology. Can we agree on that?
What? There are laws in the universe?
Yeah, I don't abide by that.
You're trying to push me over the edge today, aren't you?
Gosh, who's counting?
Nobody cares about science anymore. Not even any of us. Okay, what else have we got to talk about? Well, we have the best quote of the issue, definitely. There's no doubt about that, was that giant elliptical galaxies are something like Florida.
Yeah. Me and Sarah can represent. We both spend our time in Florida.
Mm-hmm.
What is it about giant elliptical galaxies in Florida?
Somebody from a giant elliptical galaxy.
I don't want to insult all my relatives in Florida, but the giant elliptical galaxies are like Florida because they're full of old things, I believe was Neil's point.
Yeah.
Old stars in the case of a galaxy, and old but like very vibrant people in the case of Florida.
That's right.
Right.
Of old things or old things to be, Neil then at the very end of the episode touched on M dwarfs and talked about, and he didn't actually talk much about, but there is a lot of work going on very recently here about the possibility of life existing on planets orbiting M dwarfs. And we know those stars can last a really long time. So is there a business in the future here to look for exoplanets around M dwarfs and to think about really, 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 really long-lived civilizations where you don't have to worry about 800 million years from now water on Earth is going to be boiled off and that's the end of it for Earth, because you can be there for perhaps trillions of years. Is that a viable thing?
It seems like it's becoming thought of as more and more viable, that the, where the habitable zone is or where water can exist around a star is kind of being revised a lot recently, and planets can exist around M dwarfs that can have water around them and can maybe have regions where life could exist. And the other good thing besides these stars' long lives is that they're the most common type of star in the galaxy. So there's a ton of them, which makes it statistically better for finding maybe life around them.
Yeah, it's kind of interesting. Back even 20 years ago, astronomers, I think in general, thought that most of the habitable planets in our galaxy would be around stars similar to ours. And it's not unusual. Scientists often extrapolate from a case of one and figure, well, it happened here, it's more likely to happen around something similar to us. But we've learned over those last 20 years that most of the planets that are out there are not around stars like the sun, but a lot of them are around stars that are a little bit hotter or a little bit colder, and they've even found stars around some of these M dwarfs that we're talking about, or found planets around some of these M dwarfs we're talking about. So there certainly is that expectation now that there can be lots of planets out there, and because M dwarfs are the most common stars, there may well be more planets around those stars than around any other type.
Okay, here's a question from Reddit. So the U.S. Army Moon Pinging Project was the first interstellar message with enough power to leave Earth, not the Hitler Olympic opening ceremony message like the movie Contact would have us believe. Contact wouldn't have had anything inaccurate in it, would it? Yeah. That was 1936, the Berlin Games, huh?
I'm pretty sure no one would ever put anything even mildly inaccurate in a movie or a TV show, so that just can't possibly be true.
Yeah, whether or not it's meant to be fiction, I mean, everything abides by the rules. So I can't even begin to answer that.
Well, I think the thing to keep in mind there is that the Olympic broadcast wasn't sent in a specific direction. It was basically broadcast out into space, whereas the effort to contact the moon, or at least bounce radar off of it, was directed in a certain at a certain point. So the ones that missed the moon were a lot more coherent as they got farther into space. And so if you want to talk about a message, if somebody happened to be in the beam that it was directed at, they would be more likely to pick something up like that than the original 1936 Olympic Games.
Okay, and Neil also talked about if inhabitants of other worlds had the means to perceive radio waves, their life forms would be able to intercept our television and radio waves. Are radio waves really able to travel those distances without losing energy or being distorted? And he also talked about more sophisticated technologies being in play such that people may not be listening to our broadcasts or paying attention to them. Or there may be signals from numerous extraterrestrial civilizations bombarding Earth that we're not paying any attention to as well.
Yes, to all of that. But to the first question, which I believe was, do radio waves kind of degrade as they go through space? Yes. In the same way that the farther you stand back from a light bulb, the dimmer the light is that reaches you. The same thing is true of radio waves, which are just another kind of light. So the farther they travel, the weaker a signal that reaches a given piece of space is. So the more advanced and sensitive a technology an alien civilization would have to detect it.
That's the inverse square law, they call that.
They do.
But it is worth pointing out that we do get radio signals from a long, long ways away in the form of quasars that are billions of light years from Earth. So radio waves can travel a long ways, just unlikely that the kinds of radio waves that we're sending out or that other civilizations might be are as likely to pass unimpeded quite as easily as the ones from quasars.
Right. Civilizations with transmitters as powerful as supermassive black holes will be just fine as far as our receiving their signals intact.
Yeah, I think that's one of the laws of physics.
Yeah.
One of those laws we keep hearing about. And then as for the second half of that, you know, the future technology could produce kind of the equivalent, you know, the analogous, like somebody from 1,000 years ago today would have no idea that radio and, well, maybe 20 years ago, and TV waves and everything is going around as, you know, just walking through the park. But our society has the instruments to pick that up. I mean, sure, it's possible that there could be other things like that, you know, embed messages into neutrinos or something. Like, the laws of physics are you know, well understood right now as far as we know and as far as the parts that we got. But there's so much else that we don't have a complete number on yet, that that we might be able to tweak this or improve that. That being able to forecast future technology, you can't go nuts with what people will be able to do or other beings, but it's certainly imaginable that there could be some kind of future, instead of radio waves or light signals, some Q waves or whatever, that everybody in the know is what they use in all the other planets, and we could be in the midst of a bunch of Q waves right now, like that guy in the park who didn't know there's radio waves everywhere, and we just don't have any instruments to pick them up. I mean, that's possible. Is it likely? I mean, I guess that's more of a philosophical question on how you want to look at these things.
Okay, and here's another Reddit question. Where can I find more information on what Neil Tyson said about Earth reseeding itself with life between asteroid strikes? I find this amazing.
The internet. I don't know the answer to that question.
That was a question from Reddit, so I guess we would know. Well, yeah, that isn't the most talked about theory in the world. NASA has pages on panspermia, I believe. You can see what they have to say on that topic, and then that might help lead you beyond.
Well, there are a lot of papers on early Earth and on bombardments as well that you can find. And, it's not the friendliest thing in the world maybe to look these up, and maybe not even as a neat summary, but there are a lot of papers about the incidence of asteroid and planetesimal bombardment in the early history of the solar system and of Earth, the inner solar system. So those you can check on if you want to wade into some stuff that might be a little thick. And that's where the real information is, because if you don't get into the real studies that have been done, it's sort of a lot of very general information that you could take one way or the other and not really know what's being said. And
a good way to get free papers, because scientific papers often cost a lot of money, is on a website called the Archive, arxiv.org, and there's an astronomy and astrophysics section. You can just put in keywords, and authors upload their own papers there.
Okay, and that leads right into the next Reddit question. Is there any evidence that we could discover that would virtually prove one theory or another of how life started on Earth? Or will we never really have more than an educated guess? That's a good question, and there are a lot of people, as I mentioned, working on this now, including some Nobel Prize winners, and this is an area that affects a lot of sciences where people are working together and separately, but sharing their results. Astronomers, planetary scientists, chemists, and biologists all involved in this and interested in it, and there's a lot of work, other than, as I said before, other than a few years ago having a sort of a total mystery between amino acids, the building blocks of proteins, being pretty much ubiquitous everywhere, all over, on Earth, in lots and lots of asteroids. Here's a piece of the Murchison meteorite that is a piece of a carbonaceous chondrite asteroid that was the first meteorite to have amino acids discovered in it. So there they are in pieces of asteroids from not the edge of the solar system, but the outer solar system compared to where we are. And there's a lot of work going on in just the last few years on this, of how did we get from amino acids to really complex molecules like RNA and DNA. And so the story, if you're interested in this, it's a good time to be interested in it, because the story is really developing rapidly among a lot of researchers now. And again, it's the kind of a thing where if you search keywords on the origin of life online and look for papers, you can also read a 5,000-word, a beautiful summary of where we are with this right now in the Starmus book, another plug for this book, which is coming out this summer, and that's written by Jack Szostak, S-Z-O-T-A-K, who's a biologist at Harvard Medical School and a Nobel Prize winner. That will be coming out this summer in the Starmus book, but there's a lot of writing on the origin of life on Earth. We don't know yet the answers, but there's a lot of work to get closer to where we were just a few years ago. And
I think one of the neat things
I'm
would be
sorry.
to, yeah, I was just going to say, I think one of the neat things that could happen in the future that's not totally impossible, at least, is, as Neil said, rocks from Earth have gone to other planets in our solar system, and we know because we have meteorites here on Earth from Mars that they come in the other direction as well. If we ever find life on one of the other planets in our solar system, and obviously that's one of the things NASA's trying to do in their searches at Mars and perhaps at some of the outer solar system satellites, if that life turns out to be almost identical to ours, I think that would be a pretty good sign that probably life developed once in our solar system and then got spread out by that method. And that, I think, would be a key finding. And I guess that's it. That's what I have to say.
And you might be able to find out a big clue, at least, on that by the chirality of the molecules. That is, the right-handed or left-handedness of those on Earth relative to another body in the solar system. Here's a little piece of Zagami, by the way, which is a Martian meteorite that, as far as we know, does not contain life, but fell in Nigeria in 1962 and was the largest Martian meteorite found. This is a piece that I got from Bob Haig, the Tucson meteorite dealer, a number of years ago. But, you know, this is a piece of a stone, of a Martian volcanic basalt that was flinging around the inner solar system for several million years and then came down to Earth eventually. So there is certainly a transport system of rocks between planets. Here's another related question from Reddit. I always wonder why panspermia focuses on fully formed life forms. Wouldn't it be more feasible that RNA or protogenetic material was seeded throughout the galaxy to lead to a biogenesis on supporting planets?
Yes, I think so.
Yeah.
I mean, for me, I guess maybe that's begging the question a little bit, because I guess in my admittedly limited experience in studies of panspermia, I'm not used to it being focusing on fully formed, you know, species like that. I mean, I guess kind of implicitly the bacteria is the basis, you know, what everyone kind of has in their head of, like, you know, the bugs that can, but I would consider, you know, like this, like the building blocks that will help create life somewhere else. I would also put that in there. So I mean, yeah, I agree. That's part and parcel of this kind of study, I think, and so that we shouldn't be literally focused on only already living, reproducing beings being transported by this. Also, the things that can make them happen.
Yeah, I always thought of it as more sprinkling the ingredients around rather than necessarily like a fully formed meal.
Nice.
Yeah, it's my metaphor.
And if life did originate somewhere else and then come to Earth in panspermia-like fashion, it still begs the question of where did that life start? So scientists are still going to want to figure out how life started, regardless of where it started.
Right, and it's been argued either way, or proposed either way, either components or bacteria-like organisms. But of course, the components of said organisms were already here too, we believe. So that takes a little wind out of the sail of the importance of panspermia if it was RNA or proteins or something like that. You know, it's interesting because there's panspermia. There's also the notion, and Fred Hoyle and others years ago, very controversial and funny English scientist who, by accident coined the term Big Bang and was dead set against the concept, and other interesting fun things. He was a very colorful character, and he was a guy who talked along with a number of others about panspermia quite a lot and about directed panspermia, even civilizations purposefully seeding interstellar space with organisms so that they would indeed find other planets and start microbial life on other worlds. So that there's even been a lot of scientific debate about that, the purposeful seeding of other worlds with microbial life, which gets, again, to be pretty exotic stuff.
I think that was a plot point in a Star Trek episode, that's why all the species they come across, for the most part, are like guys with funny things on their face, is because, no, actually, it's legit, you guys, because no, this precursor race spread it out, and everyone's based on the same stuff, and that's why we're all so similar. It's not just cheap costumes. So, from scientific discussions at Fred Hoyle to a Star Trek episode, once again.
That's what you're here for.
That's what I do.
It's all good as long as you're not the guy who has to be in the red shirt, right?
Exactly. If I'm in the red shirt, I am staying home that day.
Excuse me. Forgive me. I'm dealing with a few microbes of my own at the moment here. Let's switch topics just for 1 second. Here's an interesting question. What's your weirdest? We talk about the more we know about life and microbial life, the more stubborn, the more hardy, the more incredibly resilient it is, both in terms of freezing and heat and pressure and suspended states of animation for incredibly long periods. What's your favorite or weirdest extremophile?
I'm going to jump on this before anyone else gets to, because I know Bill probably wants to say tardigrade, but I want to say tardigrade too, which is in fact one of the microbes that can survive in the vacuum of space. Probably not for as long as the things that they were talking about on this episode, but it has been exposed to actual space and survived. Second to the bacteria whose name I can't remember, who live in the spent fuel tanks around nuclear reactors.
Some pretty extreme beings there, some extreme files, I almost said. I was going to say tardigrades. I feel like they've become the unofficial mascot of these hangouts, of the two magazines. They're pretty great, and they're kind of cute, and they're also called moss piglets and water bears, and they really are very extreme beings. And I guess I would also say the worms that you could find on the vents, the hydrothermal vents in the oceans, that are really kind of horrifying to look at. But to me, they're also really neat because, as Neil hinted at, kind of, they're a possibility for how life might have begun. They hint at what might be possible on, distant moons in the solar system, like Rachel alluded to. They're weird, almost ridiculous beings that thrive in super crazy temperatures and pressures and things where you would not expect to find life, and yet there they are, looking crazy and defying you to do anything about it.
And I would argue something along those same lines, except one of my favorite places on Earth is Yellowstone National Park. So I really like the organisms that have figured out how to survive in the hot pools being heated from underneath by the supervolcano that is Yellowstone.
And if you talk to chemists and biologists, that is the leading place where people believe life originated on Earth, and that those were deep-sea hydrothermal vents. So we could talk more about that, but we're beginning to run out of time. We've got another Reddit question here. During the scene about the asteroids, Neil mentioned the solar system passing through massive gas clouds at periodic times and the dislodging objects which then fell toward the sun. Can any cataclysmic impacts be traced back to correspond to one of these passing through a gas cloud? Boy, that's a real puzzle.
I think the short answer is no. There's been studies over the last several decades that have looked at periodic mass extinctions on Earth and tried to find out if there's some correlation between these things that happen, at least in some people's minds, periodically, and whether that could be a case of when Earth is passing through the plane of our galaxy, which is where most of the gas and dust clouds in our galaxy lie. And so there's been studies on that, but nobody's really proven anything, and I think the fossil record is such that it's hard to make a concrete prediction that those did correspond with one another.
Mm-hmm. And I think part of what Rich is talking about, I'm not sure if all people know that we don't just go around the galactic center. We also kind of oscillate up and down within the plane of the galaxy, so at some point passing right through the middle.
That's right. I mean, the disk of the galaxy is about 100,000 light years across, the bright disk, but it's a few thousand light years thick, and there is an oscillation up and down. You know, it's really, really incredibly hard for planetary scientists to try to wind the clock backwards and understand the dynamics of objects like asteroids and planetesimals slamming into each other. In the previous images of film, in the film strip, if you will, of the solar system, it's even harder on a galactic scale, trying to wind things backward and understand when the solar system might have interacted with other things in the galaxy, because so much of that record is lost. We know that the sun was born in an open star cluster, and that was about half of the age of the galaxy ago. And all of those stars, of course, are dispersed entirely, and all of the interactions that we've had with other objects, both near passes of stars and interstellar matter, gas clouds, and so on, and dust, really, that's a science that's really in its infancy, and we don't know whether we'll ever be able to get to correlating events that may have happened with previous encounters rotationally of stuff in the galaxy. That's really, really tricky stuff, huh?
Right. Yeah. In physics, I believe this is what we would call an n-body problem, where n is the number of things that are interacting, and n is really big, and you have to take into account all these gravitational forces and all these different directions. And after about 3 n's, it gets really hard, and there's a lot more than 3 going on here.
Yeah, the fact there are 4 N's sitting here right now, and I don't have a clue what any of you are going to say next.
Well, we're starting to run out of time here, but any final thoughts on where we are? Because we're winding down to just a couple episodes of this Cosmos series left. Any sort of final thoughts about the overall direction, about the inclusion, about things we haven't covered? Are you satisfied with this? Is this doing a good job in terms of turning people on to science who don't know so much? Who, you know, what do you sort of overall feel about the series thus far at this point?
I'll go first, and I'll say, overall for the series, I'm glad that it's happened. I feel like it has turned people on to science that otherwise probably would not have really considered it too much if Facebook and Twitter and, you know, the internet is anything to go by. The 4 of us and our extended, you know, mates can go on about what stories they should have been telling, or maybe what they left out that was really important, but in the grander sense of getting people exposed to some of the core ideas of what science is and how it impacts everybody, and that scientists are people too. They're not just these guys in lab coats with funny hair, but they're people with hopes and dreams who work and really care about these things. I guess then I'd say that the show's been a success. I mean, we can argue about the cartoons. We can talk about, you know, what else they should have been getting to, like the last 30 years worth of, you know, astronomy and science, which I think is pretty important. But it's certainly better than nothing. And I think besides this show, there's pretty much nothing. Not to discount the other occasional networks and their science-based programming, but it's really few and far between and almost unheard of on broadcast stations, which still get the vast majority of viewers. So in those terms, I think it's been a success, and I hope that it leads to more successes that we all feel even better about.
Yeah, and I would agree with that. I know we have about 30 seconds left, but if its goal is to get people really interested in science and to get, as Bill says, science on prime time and to have people talking about it, I think it's been successful. Something I hope it gets to in the next episode maybe is how our place in the universe and our conception of that has changed with discoveries like exoplanets and dark matter. Rich.
Thanks. I probably summed up what my thoughts were early on, but I agree that if it's getting younger people interested in science, then that's you can't downplay that. I think that's probably the key to this. If we can get other people interested in what we all do for a living and what scientists do for a living, and taking a look forward into the future, I think that's a key thing that Cosmos may well do.
Well, thank you so much, Bill and Rich and Sarah. Sarah will miss you in the future episodes of these, but we'll keep in touch. That's all the time that we have today. Thanks to the panelists, all of you, for a great discussion. As always, a special thanks, as always, to Celestron for sponsoring these Google Hangouts. Cosmos is taking Memorial Day weekend off next week, so we'll be back in 2 weeks to discuss the second to the last episode of Cosmos, titled The World Set Free. See you then. I'm Dave Eicher. Keep looking up to the stars.